Imagine you're just cruising down a perfectly straight road. The speed limit's like 45.
Right.
You're listening to the radio, and the traffic signal ahead goes completely dark.
Oh, yeah.
Your instinct, which has been drilled into you since your very first hour of driver's ed, screams, treat it like a stop sign.
Exactly.
So you slam on your brakes and instantly cause a massive high-speed rear-end collision. Today, we are decoding the visual language of the road to uncover why your driving instincts might actually be breaking the law.
It is a terrifying scenario, honestly, but it highlights exactly why studying for the driver's exam cannot just be this exercise in rote memorization.
Right, yeah.
If you only memorize the what without understanding the why, you become a hazard.
Yeah, absolutely.
So we are diving deep into Section 3A of the Official Driver's Manual today. That's the section governing traffic signals, arrows, lane use signals, and those pedestrian beacons. Our goal is to look at the engineering and the physics behind all these rules.
Because whether you are a student driver sweating over your upcoming written exam, or like a veteran commuter who hasn't looked at a manual in 20 years, there are traps in this text.
Oh, absolutely.
Traps that will fail you on a test or get you a ticket in the real world. We don't need to insult anyone's intelligence by explaining that a solid green circle means go.
Right. Green is go, red is stop.
Exactly. You know the basics. So let's jump straight into the gray areas, starting with what I think is the most psychologically manipulative light on the road, the yellow light.
Psychologically manipulative is a brilliant way to put it.
Thank you.
Because human behavior actively fights the engineering here. The manual states explicitly that a steady yellow light is a warning that the red signal is about to be exhibited.
Right.
If you have not entered the intersection, you are legally required to bring your vehicle to a safe stop.
Okay, let's unpack this.
Yeah.
Because out in the real world, a lot of drivers treat a yellow light like a starting pistol.
Yeah, they really do.
They see yellow, and their foot immediately, instinctively, moves to the accelerator. But looking at the manual, it specifically states that speeding up to beat the light is unlawful.
Yeah.
It's not just frowned upon, it's a direct violation.
Mm.
Why do people do this, and how is the exam going to try and trick them?
Well, people do it because of a misunderstanding of a traffic engineering concept called the dilemma zone.
The dilemma zone.
Right. When you approach an intersection, there is a specific physical window where you are traveling too fast to stop safely before the line, but you are too far away to clear the intersection before the light turns red.
Okay, so you're stuck.
Exactly. But traffic engineers calculate the duration of a yellow light specifically based on the speed limit of that road. The whole point is to eliminate that dilemma zone.
So the math is already done for you.
Precisely. If you are traveling the speed limit, the yellow light will last exactly long enough for you to safely brake if you are far away or, safely coast through if you are already crossing the threshold.
So when you speed up...
When you accelerate on a yellow, you are destroying the math. You are artificially creating a hazard.
Wow.
And on the exam, they will present a scenario like the light turns yellow, you are 50 feet from the line. The multiple choice answers will bait you with accelerate to clear the intersection quickly.
Oh, I've seen that one.
Right. But the only legal answer is to bring the vehicle to a safe stop.
That makes the physics of it so clear. You're fighting the math of the intersection.
Exactly.
And speaking of fighting physics, there's another foundational rule here involving a flashing red light. A standard flashing red light just treated like a stop sign.
Yes.
But there is a massive exam trap regarding flashing red lights at railroad crossings.
Right.
Yeah.
The manual dictates that a flashing red light at a railroad crossing requires a complete, absolute stop, even if a train is not visible anywhere on the horizon.
But hold on, because if I drive up to, a rural railroad crossing, the lights are flashing, but I have miles of visibility in both directions, and I see absolutely nothing on the tracks. Human logic said I can just roll through. Why does the manual demand treating it like an invisible brick wall?
Because of visual illusions and train momentum.
Illusions.
Yeah, human eyes are incredibly bad at judging the speed of massive objects coming toward us. A freight train can be moving at 60 miles per hour, but because of its sheer size, your brain processes it as moving much slower.
Oh, wow. I didn't realize that.
Yeah, and by the time your brain registers the actual speed, your car is already on the tracks. Furthermore, a train moving at that speed can take over a mile to come to a complete stop.
So the train's momentum simply cannot yield to your car.
Exactly. The rule exists because your eyes cannot be trusted in that specific geometric setup. You must stop, verify the system is malfunctioning, or wait for the hazard to pass, and only proceed when it is definitively clear.
Okay, so those are scenarios where the lights are actively telling you something, even if it's just a flashing red. Let's pivot to when the system completely dies. We touched on this in our intro. The manual talks about a dark, uncovered traffic signal during a widespread power failure.
Yeah, the manual mode scenario.
Exactly. The way I like to think about this is treating a power failure at an intersection like a computer crash. The automated network has failed, so the system forces everyone to revert to manual mode to avoid total chaos. The rule states you treat a dead intersection exactly like an all-way stop sign.
And if we connect this to the bigger picture, predictability is the absolute core of road safety.
Predictability.
Yes. When a traffic light loses power, predictability vanishes instantly. Drivers approaching from 4 different directions, potentially on high-speed arterial roads, they have no automated guidance.
Right.
By legally transforming that dark intersection into an all-way stop, the manual instantly restores a predictable set of rules. It removes the guesswork.
But wait, does it actually remove the guesswork? I want to push back on this because human nature isn't perfectly predictable.
Sure.
If 4 cars arrive at a dark, high-traffic intersection simultaneously, it becomes a standoff. Everyone is creeping forward, trying to make eye contact.
It's messy.
Yeah, does the manual actually account for human hesitation there? Or is it just relying on the yield to the right honor system to prevent a pileup?
It relies entirely on the established right-of-way hierarchy. You are absolutely right that a dead intersection during rush hour is a messy, inefficient psychological standoff.
Definitely.
But the manual's primary goal isn't efficiency, it's survivability.
Survivability.
Right. By forcing every single vehicle to bleed off all momentum and come to a dead stop, even if there's confusion about whose turn it is to go, any resulting collision will be a low-speed fender bender at 5 miles per hour.
Oh, that is a fantastic distinction.
Yeah.
It trades the risk of a 50-mile-per-hour fatal T-bone collision for the much smaller risk of a low-speed bumper scrape. That completely reframes how to think about that rule.
It's all about mitigating kinetic energy.
So we've seen how standard circles dictate momentum through a basic intersection. But intersections aren't just straight lines. They are complex grids where drivers have to cut across opposing lanes of traffic.
Right.
That fundamentally changes the geometry of danger, which brings us to the rules governing turn arrows.
Arrows are where the manual gets incredibly granular. And honestly, it's where student drivers often lose points.
Oh, for sure.
A circular light governs the whole approach, but an arrow dictates movement for a specific isolated lane. And again, we don't need to define what a green or a red arrow is, but we do need to talk about the flashing yellow arrow.
Yes, the flashing yellow arrow. The manual states that traffic in the proper lane may cautiously enter the intersection to make the turn indicated by the arrow.
And this is critical for the exam. You only have permission, you do not have protection.
Wait, permission versus protection.
Exactly. A solid green arrow means opposing traffic has a red light. You are protected by an invisible shield. A flashing yellow arrow strips that shield away. You must yield the right-of-way to oncoming traffic and to pedestrians in the adjacent crosswalk.
Here's where it gets really interesting, because arrows tie directly into one of the most frequently broken rules in all of driving: turning on red.
Oh, boy. Yes.
Let's look at the actual text regarding right turns on a circular red light. The manual says you can turn right, but it italicizes a very specific phrase. Before turning, come to a complete stop.
A complete stop.
Right. And I have to challenge the reality of this. Look at any intersection in America. The rolling stop is practically a national pastime.
Here it is.
Drivers drop their speed to maybe 3 or 4 miles an hour, glance over their left shoulder, and just glide right through the turn.
And they are violating the laws of physics just as much as the traffic code.
Really?
Yes. When a driving examiner is sitting in the passenger seat during your test, they aren't just watching your speedometer, they are feeling the physical momentum of the vehicle. If you do a rolling right turn on red, it is an automatic failure.
Because your brain is still processing forward motion.
Yes, exactly. When your vehicle is still rolling, even at 3 miles an hour, a massive portion of your cognitive load is dedicated to managing the steering, monitoring the distance to the curb, and feeling the car's momentum.
So you're distracted by the car itself.
You physically cannot dedicate 100% of your visual processing to scanning for a pedestrian stepping off the curb to your right. or a cyclist coming up your blind spot if you are actively managing a moving vehicle.
Wow, that makes sense.
You must feel the momentum physically cease. The car settles back on its suspension. Only then is your brain fully freed up to scan, yield, and safely execute the turn.
That makes perfect sense. The complete stop resets your cognitive load. Now, contrast that circular red with a right turn on a red arrow.
Turning on a red arrow is strictly prohibited, period.
No exceptions.
None. There is no stopping, checking, and yielding. If the arrow pointing right is red, your vehicle does not move. The manual draws a massive legal boundary here. A red circle gives you conditional agency. A red arrow revokes your agency entirely.
That is a subtle but monumental distinction for the exam.
Yes.
But I want to bring up my absolute favorite rule in this entire section. It's the perfect trivia question. It sounds completely counterintuitive, and it's guaranteed to show up on the written test, the left on red rule.
Oh, it's a fascinating exception.
Because normally, turning left on a red light sounds like a death wish.
Yeah, usually it is.
You'd be driving directly across oncoming lanes of traffic. But the manual has this highly specific carve-out. You can turn left on a circular red light only if you are traveling on a one-way street and turning onto another one-way street.
What's fascinating here is how this rule perfectly illustrates traffic engineering's balance between safety and flow.
How so?
Why is left on red allowed in this one highly specific scenario? Think about the geometry of danger we discussed earlier. When you are on a one-way street, turning left onto another one-way street, you aren't crossing any oncoming traffic.
Oh, right. Because all the cross traffic is flowing from your right to your left.
Exactly. So mechanically, your car is doing the exact same thing it does during a standard right on red.
That's crazy to think about.
Yeah, you are just merging into the closest lane of a perpendicular flow. There is no opposing traffic to T-bone you. The geometry of danger is entirely removed, so the manual permits the maneuver to keep the urban grid from grinding to a halt.
I love that. You just have to mentally flip the intersection in your head. Okay, so we've established how turn arrows manage the geometry of an intersection.
Right.
But urban grids face a very different physics problem. Directional volume changes by the hour. During the morning commute, thousands of cars flood into the city center. In the evening, they all flood out.
It's a huge shift.
Yeah, and you can't dynamically rebuild an intersection to handle that volume shift.
Yeah.
But you can dynamically redesign the lanes, and that is the genius behind lane use signals.
Right. Lane use signals act like vascular shunts in a human body, directing the flow of traffic to exactly where the system needs it most during times of stress.
Vascular shunts. I like that.
Instead of building a 10-lane bridge that sits empty half the day, engineers build a 6-lane bridge and use overhead signals to allocate 4 lanes inbound in the morning and 4 lanes outbound in the evening.
So the signals physically dictate which direction that specific strip of asphalt is moving at that very moment.
Yes.
A downward green arrow means you own the lane. A red X means the lane is entirely closed to your direction of travel. It likely contains high-speed traffic coming straight at you.
Exactly.
But there is a transitional signal, the steady yellow X. And I have to ask, because people treat this like a yellow traffic light.
Huh?
Is the steady yellow X a gentle suggestion? Like, hey, maybe think about merging in the next mile or two.
Not at all. It is an active, mandatory eviction notice.
Eviction notice.
Yes. A steady yellow X means you must move out of that lane as soon as safely possible because a red X is imminent.
So it isn't a suggestion to start looking for a gap. You need to be actively turning your wheel.
Precisely. If you treat a steady yellow X like a suggestion and wait for the red X to appear before you try to merge, you are now driving in a closed lane.
That's terrifying.
It is. If that lane is being reversed for rush hour, you are literally driving the wrong way down a highway. The yellow X exists to flush the lane of all vehicles before the directional flow is violently reversed.
Wow.
Ignoring it isn't just an exam failure. It is a recipe for a catastrophic head-on collision.
Okay, so we've covered how to manage the vascular flow of cars on shifting highways and through complex intersections. But cars are only half the equation.
Right.
How do you integrate human bodies, vulnerable pedestrians, into this high-speed vascular system without unnecessarily paralyzing traffic flow?
That's the real challenge.
You can't put a massive 4-way traffic light in the middle of a straight road just for one crosswalk. Which brings us to the most complex mechanism in the manual, the pedestrian hybrid beacon.
It is the ultimate test of a driver's situational awareness. The manual defines the pedestrian hybrid beacon, or PHB, as a special device used to assist pedestrians in crossing a street at a marked crosswalk where there is no intersecting road.
So it's a mid-block crosswalk. And visually, it's striking. It's not a vertical stack of 3 lights. It looks almost like a face. 2 red lights side by side on top, sitting over a single yellow light on the bottom.
Yes, very distinct.
And instead of reading a textbook list of steps to the listener, let's put them in the driver's seat.
Okay, let's do it.
You're driving down a busy road. The beacon up ahead is completely dark. A pedestrian steps up to the curb and hits the button. What exactly happens next?
The first thing you, the driver, will see is that bottom yellow light start to flash. This is your early warning system. It means the beacon is waking up. The pedestrian is still standing on the curb, seeing a solid, don't walk hand.
So I just maintain speed but cover the brake.
Correct. After a few seconds, that flashing yellow becomes a steady, solid yellow light. As we learned earlier, this means the dilemma zone is closing. You are now preparing to stop.
Okay, the yellow light goes out. Now both of those top red lights illuminate solid red.
This is the moment the system halts the kinetic flow of the road. You must bring your vehicle to a complete stop. Only now does the pedestrian see the walk icon. They step off the curb and begin crossing your lane.
Stop and stay stopped makes total sense. Here is where the sequence breaks the brains of veteran drivers.
Oh, absolutely.
The pedestrian makes it across your lanes. They are safely on the median. Suddenly, those 2 solid red lights change. They start flashing in an alternating back and forth pattern, like a railroad crossing. Am I supposed to just sit there paralyzed while these red lights flash, even though the crosswalk right in front of my bumper is completely empty?
This is the genius of the pedestrian hybrid beacon. You do not just sit there. The manual states that during the alternating flashing red phase, you must stop, which you already have verified, that the pedestrian has cleared your lane and any adjacent lane, and then you may proceed.
Wait, so the flashing red simply reverts to a standard stop sign rule?
Exactly. While the lights are flashing red for you, the pedestrian is looking at a flashing countdown timer, telling them not to start crossing if they haven't already. The system is designed to hold the pedestrians back, but immediately release the stopped cars as soon as the physical danger has passed.
Oh, I see.
It allows the heavy traffic flow to resume much faster than a standard traffic light would.
That is brilliant engineering. You stop, you check, you go. But we cannot wrap up this section without returning to the scenario I posed at the very beginning of this deep dive.
The dark beacon.
Yes. The pedestrian finishes crossing. The flashing reds turn off. The beacon goes completely dark again. Earlier, you explicitly stated that a dark, completely unlit traffic signal must be treated as an always stop.
I did.
But the manual contains a massive exception for this specific mid-block beacon. It literally says the state statute requiring vehicles approaching a dark traffic signal to stop does not apply to pedestrian hybrid beacons.
Yeah.
When I first read that, my jaw dropped.
Mm-hmm.
It feels like a lethal contradiction. Why on earth would the manual tell you to stop for a dark intersection but blast right through a dark mid-block beacon?
Well, this raises an important question about physical context. You cannot separate a traffic rule from the geography of the road. Think about where a standard traffic light is located, an intersection,
Yeah.
2 roads crossing.
Right.
If the power fails there, you have a massive conflict zone with cars approaching from 4 directions. You must force a stop to prevent a T-bone crash.
Right, our kinetic energy mitigation strategy.
But look at the geography of a pedestrian hybrid beacon. It is placed mid-block. There is no cross street. Cars are only flowing straight along a single axis. If the beacon is dark, it simply means no pedestrian has pushed the button.
Of course.
If you, as a driver, suddenly slam on your brakes in the middle of a straight road with no intersection just because you saw a dark piece of metal hanging over the street.
The driver behind me, who is just cruising down a straight road at 45 miles an hour, has absolutely no expectation that I'm going to drop anchor.
Exactly. Stopping for a dark signal in this specific geographic context wouldn't prevent a crash. It would actively cause a massive rear-end collision. The rule changes because a physical environment changes. The manual forces you to keep driving to maintain the predictable flow of the straight road.
So what does this all mean? We have decoded a tremendous amount of Section 3A today. We've moved from the strict physics of braking for a yellow light, to the visual illusions of a railroad crossing, to the fluid dynamics of lane use signals, and finally, the geographical context of a mid-block pedestrian beacon.
We really covered a lot.
We did. And if you are preparing for your driver's exam or just trying to be a better driver, The major takeaway is that the road is a dynamic, physical system constantly communicating with you.
It absolutely is. And my challenge to you, the listener, is this. Don't just close your browser and leave this knowledge floating in the abstract.
Yeah, use it.
The next time you are in a car, turn the daily commute into a real-world scavenger hunt. Look for the flashing yellow arrows. Spot the lane use signals acting as vascular shunts over a bridge. Watch how other drivers behave at a solid yellow light versus the strict mathematical reality of the dilemma zone.
That's a great idea.
Seeing these engineered systems function in the physical world will lock this knowledge into your brain far better than staring at a printed manual.
That is fantastic advice, a real-world physics scavenger hunt. As we close the book on this deep dive into the visual language of the road, I want to leave you with one final thought to mull over. Think about the massive difference context makes. We learned today that a completely dark light at a four-way intersection demands maximum caution, a mandatory absolute stop to prevent catastrophe. But a completely dark light at a mid-block pedestrian beacon means normal flow. Keep your foot on the gas, because stopping is the catastrophe.
Context is everything.
It proves that out there on the asphalt, where a rule applies, is just as vital to your survival as what the rule is. Keep your eyes open, respect the physics, and good luck on your exam.